Question 1. 4 linear models have been developed for a dataset. Identify the residual plot that indicates that the developed linear model is justified. So, in order to justify whether a linear model is appropriate or not, the resultant residual plot will show the data points scattered above and below the line, i.e., there's no discernible pattern. So, what we're looking for is data points above and below the zero and no discernible pattern. So if we have a look at our residuals, or the residual plots I should say, this line here is going to be our 0. Okay, so the first bullet point says that data points above and below the 0. Well, straight away we can see that B, all the data points are above the 0. A, C, and D still have data points above and below, so they're still valid contenders. But if we have a look at our second bullet point, it says no discernible pattern. Well, if we have a look at A, we can kind of see a pattern. It starts above, it goes below, then it comes back up. And if we have a look at D, it starts below and it just increases constantly. Okay, but C, you'll notice, hey, the data points are scattered above and below. So the logical choice here, guys, would be C. Question 2. The standard Australian time zones are shown on the map. All states and territories except Western Australia, Queensland, and the Northern Territory have daylight saving in summer. Daylight saving time is 1 hour ahead of standard time. When it is 10 a.m. daylight saving time in New South Wales, it is A, 9:30 in South Australia and 9 in Queensland, B, 9:30 in South Australia and 11 in Queensland, C, 10:30 in South Australia and 9 in Queensland, or D, 10:30 in South Australia and 11 in Queensland. When we look back at the question, guys, it says when it is 10 a.m. daylight savings time in New South Wales, what is it for everything else? So the quickest way to go about this is just label our states with the times. So we know in New South Wales it's daylight saving time and it is 10 o'clock. We know Queensland is on the same time zone, but it doesn't follow daylight saving time, so it's an hour behind. So it's going to be 9 o'clock in Queensland. South Australia follows New South Wales and has daylight savings and is half an hour behind, so it will be 9:30. The Northern Territory is half an hour behind Queensland and doesn't follow daylight savings time, so it would be 8:30. Western Australia also doesn't follow daylight saving time, and it is 2 hours behind Queensland, so it would be 7 o'clock. Now, let's have a look at our options. When it's 10 a.m. daylight saving in New South Wales, A, 9:30 a.m. in South Australia, check, and 9 a.m. in Queensland, check. So our solution for question 2 is A. Question 3. For the sequence 4, 2, 0, -2, -4, the common difference is A, 4, B, 2, C, -2, or D, -4. Now the key words in this question is sequence and common difference. When we think of a sequence in general mathematics, we should think straight away geometric or arithmetic. And when we think about an arithmetic sequence, we should be thinking about a common difference, and a geometric sequence, we should be thinking about a common ratio. Now, as this question talks about a common difference, we should understand that the sequence is going to be arithmetic, and there will be some common difference, D. Now, in order to find D, we have a little equation to make it more formal of Tn plus 1 minus Tn. But really, what that is saying is if I take any term and I subtract the previous term from it, I will find my common difference. So let's do that now. If I take the term 2 and I subtract the term before it, which is 4, we will find our common difference. So 2 minus 4 gives me negative 2. So D, our common difference, is negative 2, which means the solution for question 3 is C, negative 2.
Question 4. Which of the following graphs could be modeled using a geometric sequence? So when looking at a geometric sequence, we're looking at a sequence where each term is multiplied by what we call our common ratio, or our R value. If I was to graph those R values, we have two situations that we're going to look at. We're going to look at when the R value is between 0 and 1, and we're going to look at when the R value is greater than 1. So as you can see on the graphs over to the right-hand side here, when R is between 0 and 1, we have a decay graph, right? And when R is greater than 1, we have a growth graph. So looking at our four choices here, A, B, C, and D, right? Which one is most applicable? So if we look at A, we see A comes up and then it seems to peter out. So it's neither growth nor decay. B seems to have a parabolic shape to it. C almost looks like it's constant going down. So actually C could be an example of an arithmetic sequence. But D, which is our solution here, it comes down in a decay graph. So the solution for this one is D.
Question 5. Determine the equation of the least squares line where R equals 0.926, the mean of X equals 5.2, the standard deviation of X equals 2.3, the mean of Y equals 68.6, and the standard deviation of Y equals 41.7. Now, in order to find this equation, guys, you're going to have to go to your formula booklet and have a look under statistics and find the formulas that relate to the least squares line. So if I bring them up, we can see these down here. We have the least squares line slope and the least squares line intercept. You'll notice that in order to find the least squares line intercept, you need to know B, and that is only found by first finding the least squares line slope. So let's use these formulas and substitute in the information we're given in order to find our equation. So first of all, in order to find B, we need to substitute in R and multiply that by the standard deviation of Y over the standard deviation of X. In this case, R is 0.926, and we're multiplying that by 41.7 divided by 2.3. Okay, let's bring up our calculator and have a look at that. So 0.926 multiplied by, let's put our fraction button, 41.7 on 2.3, and we get a solution of 16.79. So that's our slope, guys. So that's what's going to be attached to our X variable. So straight away, we can rule out C and D. Okay, let's have a look now for A. A, let me get rid of my calculator here. A is going to equal the mean of Y minus B times the mean of X, which in this case will give us the mean of Y is 68.6 minus B, which we just found, 16.79, times the mean of X, which is 5.2. Let's put this into our calculator and see what we get. So 68.6 minus 16.79 times 5.2. Now, when I'm entering this information into my calculator, guys, I like to use brackets. And if you do use brackets, you should really get used to closing them as well. So our solution there is negative 18.71. So let's have a look, okay? A is negative 1,146. That's not right. So our solution has to be B. Now, just a side note, guys, if we have a look at the least squares line intercept for B, it's saying it's negative 18.70, but we got a negative 18.71. And that's okay because we rounded to 2 decimal places, and when rounding to 2 decimal places, you should always look at that third decimal and round accordingly, which is what we've done.